All right, let's get started. So tonight in online office hours, I'm going to do certainly, and I'm going to check my mic real quick in just a second, but I'm going to work on test prep, take any questions that my face-to-face classes have. If they'll come on here and give me just a few minutes of their time, then I'll answer any questions they've got. They can just put it in the chat, or I can bring you in. I can give you a link and you can come in. Yeah, we're here. And there we go. Okay, so I've got my screens up here. I'm trying a little bit different configuration tonight. It's just me on right now. I don't think anybody else is. So certainly I've got what I need from the homework that I sent home with you. We're going to talk through some of those problems if nobody shows up. And then here I've got my TI-84 calculator. And on this side, I'm using GoodNotes now instead of Doceri. So I'm trying to find a replacement for Doceri. I've mentioned this on here several times for the few in the world who may have come across it before. Doceri is not supported anymore. I think the company is defunct. I don't think it's around anymore. So, because it's not around, I'm worried that it's going to disappear at some point. And if it disappears, what's going on here? So if it disappears, I don't want to be up and running with it and lose it. So in GoodNotes, I already have that on the iPad. And so whatever I put on here, I can keep, and whatever I prep for my streams, I can put on here. Now tonight, I didn't do any prep because this is an online office hours. I'm here to take your questions. However, in the future, if I get everything up and running, then instead of having my screen here where I've got another Google page pulled up, which pulled some resources on this Mac, then I could have all my stuff put right in here in the notes, and I could always reflect back on it. I could bring up this semester after semester and be somewhat consistent with it. Right now, whatever we've covered, and of course this is a summer term, and with the summer, I'll bring the mic a little closer. Sorry about that. With the summer term, it is a 10-week instead of a 16-week course, so it's tougher to manage and tougher to stay consistent when I'm built for the semesters, and then we truncate that by 6 weeks. Not impossible, and I could certainly redo it. But anyway, there I am. So I am streaming tonight with Restream instead of Ecamm. So it may look slightly different for anybody that's noticing the differences. But I use mirroring 360 to get my iPads up on the screen, and then I just pull my whole screen in there. And instead of going back and forth between screen shares, which kind of eats the resources of Restream, I just scroll back and forth on my Mac. So I've got all three of these screens right here. I can do my work. If I have to refer back to the problem, there I am. If I want to use the calculator, there I am. So, okay. So what I'm going to do is there is only one person on, and that one person is me. So I'm going to go ahead and get started. What I'm going to talk about one second. Sorry, a little bit distracted just looking across the top of my screen there. Okay. What I'm going to do right now is I'm going to work through just a few of these problems. I certainly won't do all of them. These are your homework problems. Do not forget that if you were in class, I did this as a handout. You have to bring it back before the test and turn it in. These are problems that prep you for the test. This is a session that you can come on and ask questions about these problems. And these are only a small sample of what you might see on the test. Last Wednesday, we did another review with probability and regular basic probability, discrete probability distributions, and also binomials. And I'm going to walk through binomials again tonight. Excuse me. And then I'm going to walk through just a few of these problems with discrete distributions. I will also talk tonight about the mean of the distribution and the variance of the distribution and the standard deviation. And I'll do that with these top ones. And so what I'm going to do, without Doceri, I'm kind of a little bit of a disadvantage, but not really. Let me do this. Let me draw this one out. It's a very small one. So let me take just a second. Then I can do all my work right up here, which is what I should have done. Again, back to I did not prep for this particular night because this is online office hours. 0.28, 0.21, 0.43, and 0.15. I actually like the look of GoodNotes. Yeah, there we go. That shows up pretty good. And so, okay, I'm going to assume that this is a basic probability distribution here. So this is not a binomial. Of course, we have no context for this. You're just given a distribution. And the question actually is determine whether this is a probability distribution or whether it's not. And so I'm going to go right down here. In order for this to be a discrete probability distribution, then it has to meet certain criteria. The summation of all the probabilities has to be 1. So I've got 40, 50, 60, 70, 80, 90, 98. This is too big. This is too big already because I've got 40, 50, 60, 70, 80, 95, 98, 99. It's too big. So this particular one does not equal. And the fact that it doesn't equal 1 means that it is not a discrete probability distribution. And remember, when we were building them the other day and constructing them, every once in a while, if you round or if you truncate to keep it in the table, you may find that when you do the sum, that you get a number like 1.001 or a 0.997, something like that. So you're right there at 1, but you're not quite 1. So didn't fit the criteria. So what I'm going to do is I'm going to make it fit the criteria. So I'm going to take this 43 down, and I'm going to add this one, and this one together, right? Very easy. So I've got 20, 40, 50, 55, 56, 66 minus 2 is 64. So I've got, let me just, just write out here. So the sum right now is 0.64. So I got 74, 84, 94. So I got 36. So I'm going to put 0.36 right here, and I am now good. Because now I got 30, 40, 50, 60, 70, wait a second, 30, 40, 50, 60, 70, 80, 85, 91, 92, 1. So now my sum equals 1. All of these probabilities, the sum of the probabilities equals 1, and all of these probabilities, one thing that I did not talk about a second ago was that the sum of the probabilities themselves, we did the sum. The probabilities themselves should fall between 0 and 1, right? Okay, and they do. We're good there. That's no problem. So let me erase this out. Okay, let's find the mean of this. Let me switch to a blue color. So let's find the mean of this. So the mean of this discrete distribution is just going to be the summation of the x's times the probability of x. And so in my class, you may be thinking, how do we know it's not a binomial? Because I'm telling you it's not a binomial. From the picture on the sheet, we really didn't know. Like, whoops. From here, we really didn't know. Decide whether the distribution is a probability distribution. Explain your reasoning. This one was not as written, so I changed it to fit. There's no context here. I didn't arbitrarily choose the numbers. I chose the numbers that would fit. So put that 0.36 in there and replace the, what was it, 0.4443. This is what I have to do. If you remember, now, let's see, I think I've got room here. I could just say 5. So I could take these two right here, plus those multiplied together, plus that one multiplied together, plus that one multiplied together. And in such a short problem, it's not hard to do that. So I could say 5 times 0.28, and that x is just a big multiplication to show up on the screen. Sorry, it's not a variable. Plus 6 times 0.21 plus 7 times 0.36. I'm going to jump down here below because if I go there, it's going to go to the next sheet. And then we'll go plus the last one, which will be 8 times 0.15. Okay, So I'm going to actually just do that real quick on the calculator. It's not hard calculations. 5 times 0.28, and I get 1.4. So right here, that term is 1.4. 6 times 0.21, 1.26. 7 times 0.36, 2.52, and 8 times 0.15. All right, 1.2. So I found everything I needed to find right there. All I need to do is add them together. So 1.4 plus 1.26 plus 2.52 plus 1.2. If you see me look up like a crazy person once in a while, it's because my camera's here and I'm looking there and my iPad's here, so I'm trying to see if I'm still showing up in the picture or if I'm sitting off to the side like this. Not that anybody wants to see me, but I don't want to look stupid. So the mean for this is equal to 6.38. 6.38 is somewhere right there. So that makes sense. This is a fairly balanced, as far as the four numbers go, probabilities, fairly balanced. So that measure of center actually is pretty close to the center of this distribution. Nothing is pulling it out. There's no huge values at one end or the other that's skewing it out one way or the other. So that was that. Okay. Now let me switch. I'll just switch colors here. Now let's talk about this in terms of the calculator. So, and I've done these on here before, but just as just kind of a walk back through before we go into the test on Wednesday. If I take my x values and put them in L1 on the calculator, in other words, I go stat, enter, and I put 5, enter, 6, enter, 7, enter, and 8, enter. And the commas don't go in there. That's just me signifying the enter. So I put those in L1, okay? And then I take the probabilities and put those in L2. So I do the same thing. So then I go 0.28, enter, 0.21, enter, 0.36, enter, 0.15. If I put those in there, then in L1 I've got the x values, and in L2 I've got the probability values, right? So then, and I'm going to walk through it with the calculator in just a second. I'm just kind of walking through the steps. Then I would go back through, and I want to look at this particular equation in terms of the table columns. If I've got the x, let me rewrite this. If this is the summation of x times the probability of x, then in the calculator, what this really looks like is the summation of L1 times L2, because that's where my values fall. You don't throw out the summation, but in what we're going to do in the calculator, all that does is fill in the values, the terms. So it fills in this value, and this value, and this value, and that value. So it shows those on the calculator. Once it shows those on the calculator, then I have to go. One second, that was my son calling. I'll call him right back. So once I do that, then I have to back out of the cell sheet so I don't incorporate something in the cell sheet shouldn't be there. And then I go second, stat, scroll over to math, scroll down to sum, and take the sum of L3. I'm about to walk through that right now. So I'm going to put the numbers in here while I've got them up here in front of me. Clear. Ben, I gotta let you go. I'm streaming right now, buddy. I'll call you back. No problem. Bye. I figured that was easier than... I'm not trying to dismiss him. I just want to get through the stream unless it's an emergency or something. So, you got 5, enter, 6, enter, 7, enter, 8, enter. We are working with a discrete probability distribution. 0.28, enter. 0.21, enter. 0.36 enter and 0.15 enter, right? So we got all that in there. Okay, now that I've got it in there, I don't have to refer to this screen. I will come back to it because we're going to get this term, this term, this term, and this term, and I want you to see that on the calculator. So I go in here and I scroll over and scroll over, and there we are. I've already put the numbers in. So I've got the x values in the L1 column. I've got the probabilities in the L2 column. Now what I'm going to do is I'm going to scroll up to L3 where it's highlighted pink. You can't put the formula in the cell. You have to go to the column header. And I'm going to put the formula in just like I outlined for you here. It's basically L1 times L2. So I go second L1 times second L2. I haven't hit enter yet, but you see that it filled in. And what did it fill in? 1.4, 1.26, 2.52, and 1.2, which is exactly what we got on the previous page, right? 1.4, 1.2, wrong direction? No, not far enough. There's the 1.4, 1.26. You see them right there, 2.52 and 1.2. 2.52 and 1.2. Great. So now I just hit enter, and on this calculator it finishes it out. Excuse me. And now I'm going to back out of the cell sheet. So I'm going to go second mode, which quits out of there. I'm going to clear this just for OCD reasons when it's all gone. That was what I was doing a second ago, just computationally. So now I'm going to go to second stat, scroll over to math, scroll down to sum, hit enter, and we have our term, each individual term values, the product of L1 and L2 listed in L3. So I just do the sum of L3. Ta-da! 6.38. Is that what I got? Yes, yay. Same thing. So we did it this way on paper because it's just a few numbers. It's probably as easy to do it this way as the calculator. But if you have a whole lot, then technology comes in handy. And if you're worried about mistakes, you can always go back here and look at them, especially if your handwriting is poor. Now, my handwriting tonight is not too horrible. It's not too bad. So there's that. We just found the mean for this. And now what I'm going to do is I've got the numbers in L1 and L2. I'm going to erase this off, and we're going to look at the variance of a basic discrete probability distribution. This is not a special case like a binomial. And it is that way. Again, you may be, as a student, thinking, well, how does he know that? How can he define that? We talked about that in class with determining whether it's a binomial or not a binomial. Because in summer term, we're just working with those two, the basic and then a binomial. So we talked about that, but in this case, this is just an arbitrary from a problem that doesn't give you any context. Okay, there, I've said it, talked long enough. All right, just you have to watch me erase for a second. I'll leave the blue line up there that indicates the mean. So let's go back to this. Let's go back. I think I used blue last time. So we'll go back to blue. So now we're going to find the variance, and ultimately we're going to find the standard deviation once we find the variance, but the mathematical relationship between variance and standard deviation hasn't changed. If you find the variance, you can take the square root of the variance. Ta-da! You found the standard deviation. Our form that we've derived in class for the variance is the summation of the x values, subtract the mean, squared, little x, just represent multiplication, times the probabilities. It's very similar to before. Now what we had for we had 6.38 for the mean. Now what you could do, and let me go through this. These are in L1. L2, this is 6.38. However, you could also designate that formula to look like this. L1 subtract the mean I lost my place. There we go. The mean of L1, close the full parentheses, square it, close it again, times L2. You could do that. You could find all of that together, but it wouldn't pull out the mean. And for assessment, as I showed you in class, I'm going to have a little place for you to put the mean. And I need the mean to be separated out, so it's easier to find the mean first to put it in. But you could do this. So let's go away from that. I guess I just want to rewrite it because I accidentally erased it out. Okay. So basically we are going to have a double parenthesis, and then on a TI you have to be very careful with parentheses because it would read the one second. That's it. So we got L1 subtract 6.38. It will read things. It will multiply before it does everything else, or add before it does something because of the way you've got it set up. So you double parenthesis that, and then you multiply it times L2. That's what we're about to work with. So I'm going to scroll back over. I've already got these numbers in the calculator. 1, 2. Go back to, oops, trying to click on there. I'm just going to scroll up and clear that out. We don't need those anymore. I'm going to scroll back up and I'm going to put exactly what I just put on here. The order of operations is going to be okay because I'm going to double parenthesis it. So I've got second L1 subtract 6.38, close parenthesis, square it, close that completely out, and then just go times L2. And again, it fills in below. So that 0.5332 is saying 5 subtract 6.38 squared times 0.28. So I'm looking here from the equation. 5 subtract the mean of 6.38, square whatever you come up with, then multiply by this, then you get this. That's each individual term right here. I have to back out of this, so I go second mode. Second function of the mode button is quit. And then I go to second stat, scroll over to math, scroll down to sum, the sum of L3 again. Now you have to be careful. I cleared out 3 and put it back in 3, but if you went to L4, you have to remember that and go to L4, otherwise you'll be way off on this. It happens, so if you're taking an assessment, always double check it. It happens to me sometimes when I'm going through. I get sloppy, so to speak, and I don't clear it out and don't use L3 again. I use L4, which actually is okay, but I forget about it. So I've got 0.10956. If I want to find the standard deviation, I take the square root of the variance, and I get 1.04. So let's go back and write out our answers. Okay, so I've got what I get for this was 1.0956. I took this to find the standard deviation. I took the square root of the variance of 1.0956 and did it on the calculator, and I got 1.0467, which go out 4. 0467. There we go. So there it is, standard deviation, and right up above it is the variance. So I have found in a basic probability distribution, I have found the mean, and I have found the variance, and I have found the standard deviation of all of those. So easy enough. All right, I'm going to do a little. By the way, you're really working with a great influencer here. There's a lot of good stuff going on. There's one person watching the stream, at least on YouTube. I also have this going to Twitch. I don't know why. I just using a restream, so why not? I'm quite the influencer. You get to hear my dog bark. Every time I stream, my puppy barks. At nonsense, nothing. I don't understand it. But look at all the people that have showed up. Nobody. I'm logged in on my phone. That's my one person. It's okay. I do these videos for online office hours for my folks to ask real-time questions if they need to. I try to do them every Tuesday and Thursday. Sometimes I'm unable to be there, but I'm fairly consistent with it. When I get done, I put a little cover page on it, and then I put it on our Moodle site for the face-to-face class. Any face-to-face class I'm teaching, I just put it right up there. and so people can refer back to it. And I do see that people go back and watch it. I don't know how long they watch it. I don't really look at the analysis of it, but hopefully it's somewhat helpful. I always ask open-endedly for feedback on this. So if anybody has feedback in the comments, be sure to leave them like, hey, I liked it, maybe you could do this. Hey, you used good notes, maybe you could try Nebo or something for a long page that you can continue working with, which you can. But anyway, let's look at another problem. I think I was going down the road of you're working with quite the influencer. But I was going to take a break. What I wanted to do, a break in the sense of I want to go to the next page, but it's taking me back to the old page. How do I do this? I'm just going to erase it off and keep working just to keep the flow going. But I got to figure out, because what I did was expand the page so I could look at my screen sideways. And I'm basically just talking to myself because I don't think, first of all, nobody's on. And second off, I don't think anybody's concerned on what I did with GoodNotes. But maybe, just maybe, somebody out there is like, Mike, thank you so much for going into so much detail on stuff that is really useless. All right, so I have erased off the screen here, so now I'm back here. So let me pull that second number 2 up there. We're trying to decide whether the distribution is a probability distribution. Explain your reasoning. What I'm going to do here is go through this one a little bit quicker. If it is not a probability distribution, it's not a probability distribution. I can go ahead and tell you. But if it's not, then I'll change the numbers until it fits. So I've got thank you, Lucy, for being so loud and proud. Barking at nothing. 1/2, 1/4, 5/4 minus 1. Okay. Let me scroll over here. Let me scroll over here, but let me just step off for just a second. I will be right back. Yes. Okay, sorry about that. And my mic was probably on, but I had to go in the other room and try to get her to be quiet. And she did. She calmed down. And then my wife asked some questions about tutoring chemistry. Anyway, is this a probability distribution? Well, let's look at the constraints again, just to reiterate. And if you just walked in, I'm coming in off a break because my puppy is crazy. And oh my goodness. Well, let's take a look at this. And I have to charge my Apple Pencil. So anyway, is this a probability distribution where there are two constraints that we have to look at? Are all the probabilities, do they all fall in the range of probabilities rule between 0 and 1? No. 1/2 does, 1/4 does, 5/4 does not, and -1 does not. So what I'm going to have to do is change these, not as a researcher. If I was a researcher, then there'd be a flaw somewhere in the numbers that I've gathered. But for this problem set, just for a teaching moment, I'm going to change this to be something that will work. And then I'm going to quickly, and I say quickly because I've already walked through piece by piece slowly, I'm going to find the mean, the variance, and the standard deviation again. And then I want to move into binomials because I've been on now for about 30 minutes. So I've really only done one of these. So let me see if this is now back up and going. No, well, yes, it is. Let's see how long it lasts. So let me do this, and let me just erase off these. So, and this one. Go back to here. All right. So let's go 1/2. Let's go. No. We could, but I'm gonna do something with it, some different numbers. I'm gonna go just easier for me to finagle. Let's go 1/6, 3/6, 1/6, and 1/6. 3, 4, 5, 6. 6 over 6 is 1. That the sum is 1, and all of those fall between 0 and 1, so we are okay. So now quickly, or quicker than before, I go to the mean. Standard, this is not a binomial distribution, this is just a basic discrete probability distribution. So we be looking at this as our form, and that breaks down to be 1 times 1/6 plus 2 times 3/6 plus, I'll go down below, 3 times 1/6 my connection from mirroring for the calculator piece has been constant, but for GoodNotes it has not been. So I'm going to go back to, I think I'm in here. Once I get there, I go there. Yay, it's still there. Okay, 3 times 1, yeah, and then plus 4 times 1/6. Okay, so now I'm going to find each of these numbers. So 1 times 1/6 is 1/6. 2 times 3/6, what would that be? That would just be 1. 3 times 1/6 would be 3/6, which would be 1/2. And 4 would be 4 over 6, which we would, as always, reduce. 2 goes into 4 2 times, 2 goes into 6 3 times. That's where I end up. No problem. Well, there's some basic stuff. So there's the numbers that I've got. So this is gonna, this is gonna be about 0.17. This is 1. This is 0.5, and this is about 0.67, right? So to put them in decimal form, so we got that, and that. So I'm stating that my mean is going to be 0.17 plus 1 plus 0.5 plus 0.67. And I get as the mean 2.34. So I get the mean equals 2.34. I write that at the top as a reference. So now I'm going to go back, or now I'm going to go in the calculator, and I'm going to edit it off screen here, because it won't take me but a second. And I have to look at it while I'm going through. So I got 1, enter, 2, enter, 3, enter, 4, enter. There's L1. For 2, I've got 1 divided by 6, enter. I've got 3 divided by 6, enter. I've got 1 divided by 6, enter. And I've got 1 divided by 6, enter. Okay? So let me do one thing real quick. Okay, I'm ready. So now I'm going to put the formula in, and if you remember, oh, Mike, this thing, yippee. Okay, if you remember, the formula, in fact, let me reiterate the formula just real quick, right here. So this is going to equate to L1, this is going to equate to L2, so that's my form that I'm going to use. So I scroll back over. I really like this GoodNotes. I'm finding a niche here with this, with the stream. For me, just talking out loud. So second L1 times second L2, enter. There they are. Second quit. Second stat. Scroll over to math. Scroll down to sum. I got it in L3. 2.33333. Is that what I got? Let's go back and find out. Yes, I had 2.34. Good enough for government work. So I had 2.34 as our mean. We're 2.3s repeating. But I took that 1/6 and made it 0.17. And I made 2/3 into 0.67. And so on. So there was a little to recoup there. So we're okay. There's the mean. Yay. All right. Now I'm going to erase all of this off. And I got the mean up there. Okay. A few glitches here and there with this jumping off, me having to put it back and having to go back and forth between the calculator. Other than that, this is running well with Restream. And when I go back and watch it, then I'll really know. This is just 1080/30. So anyway. Again, Mike, you gotta stop. Nobody's listening. Let's go with light blue this time. And let's go for the variance. And that is equal to the summation of the x values, subtract the mean squared, times the probabilities. Okay. Now, we're jumping straight to the calculator. And what that's going to look like is, let's see if we can go with, oh, that's not good. Too light. Let's go with a purple. L1. The mean we found, which was, depending on how you look at it, we're going to go 2.34 for this example. And that's L1, and the probabilities are in L2. So our formula, if I can squeeze it down here at the bottom, is, what we're going to put in there is double parenthesis L1 subtract 2.34 squared, close the parenthesis, times L2. Okay. Scroll back over. Second, stat. Oh, no, stupid. Come on, Mike. Stat. Scroll over. Nope. Enter. I'm back. Okay. Clear. There we go. Now I'm going to scroll back up to the top of the column because that's where I have to put my formulas at. And just like I told you, I'm going to double parenthesis it. I go second L1, subtract 2.34, close, squared, close. For order of operations on the TI, sometimes I put extra parentheses. Maybe it's not needed, but I have run into too many situations where I didn't, and it went awry. So I now have times second L2. There's my formula. You can see it right there at the bottom. That's at the very top of L3. Hit enter, and I get these numbers as my term values for each one of those terms that I would have in the summation. I don't need to do anything else except find the sum of L3. Add one thing to one thing to one thing to one thing. So I'm going to go, oops, I'm going to go second quit, second stat, scroll over to math, sum of L3. Okay. Then I'm going to scroll back over, and the sum that I came up with, yeah, I'm liking this a lot, by the way. I'm liking it better than Doceri. I don't know why I didn't go with Good Notes a while back. And again, if there's any educators that pop on here and they're like, what's this guy doing? This is Good Notes. And I really feel like I can have one tab up here, like if I switched right now to this was just something else I had up there. I could go from a set of notes back to the live stream board. I got to figure out how to extend the board and make it infinite so I can move it around a little bit more, but I can do that offline. So I got, first of all, back to the color. I'll go 4 places. I got 0.889, no, 888. 8889, sorry. Yeah, if I don't have my glasses on, sometimes it squeezes together when I'm looking at the small numbers on there. So there you go. There is your variance. Yay. But we also had to find the standard deviation. Well, that becomes very easy to find because it's just the square root. It's the same mathematical relationship. So we go here, 0.8889. I don't know what it is. I haven't figured it out yet. 0.8889. I got 9428. There's my standard deviation. And there it is. So I feel like two very good examples showing up on GoodNotes, showing up through Restream, I think, very well. So hopefully this helps a little bit. Remember, if you're in my class, just let me know if you have any questions, and I'll bring up the chat. I think I kept the chat down. I'm sorry. So somebody wants me to add them on Discord. Okay, maybe. Okay, but two very good examples. Now we're going to move to a binomial distribution. I got excited. I saw people in here, and I was thinking, I'm excited people are in here, but I was hoping that somebody from class was coming and asking some questions. So again, if you're in here, you're from my face-to-face class. That's what this is online office hours. By all means, ask some questions. So let me erase this off. Let me erase the board. I think there's a better way to do this. So I think I can erase the whole thing. I just can't remember. This only takes about 4 seconds. So anyway, there's that. Let me scroll over. And let's scroll down. I'm getting away from these. Blah, 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 blah. Find the mean variance standard deviation. So first, if you had one like this, as you know, we did plenty of these in class. You have to add all of these up and then subtract from 1, and that gives you the missing value because the sum should be 1. Just things you should know about the distributions. I'm not constructing a distribution tonight because I did several in the previous videos. And now I'm just going to do one of these binomials. We did some in class the other night. I just want to walk through one of them. So we're going to look at answer guessing. While I'm reading through it, I'm going to write down some of the pertinent information on my board, and then I'll scroll over to the board. So there are some limitations to my setup. My setup, by the way, I've got one iPad with the calculator, small one, regular size. Both these are older iPads. The second one is a 10.2 inch, I think, iPad. I've got my older Mac with some screens. So if you see me looking all around, look confused sometimes because I'm trying to go one or the other. This is not a high dollar, but I'm hoping it helps my students in class. That's my goal. All right, answer guessing. Number 17. This is from a previous book that I had used way back when. You are taking a multiple choice quiz that consists of 5 questions. Okay? Each question has 4 possible answers, only one of which is correct. To complete the quiz, you randomly guess the answer to each question. Find the probability of guessing exactly 3 answers, at least 3 answers, and less than 3 answers. And we'll come back to that as far as the A, B, and C. So what do we have? Do we have a finite number of trials? We do. We only have 5 questions. So let me write that down. We have 5 questions. Each question has 4 possible answer choices. So if only one of which is correct. So if there's only one correct answer out of 4 answer choices, that means if you are guessing and you have no idea, then you have a 25% chance of getting the correct answer by guessing. So we're going to build this is a binomial distribution because the probabilities for success, which is guessing the right answer, remain the same throughout each trial. There's a finite number of trials, as we covered in detail in class. I apologize for my puppy again. Really, she's a nut. It's really crazy. Very sweet dog, but crazy. So 5 questions. The probability of success is 0.25 because the outcomes for the random variable x are exactly 3 answers correctly, at least 3 answers correctly. So that's what I'm looking for with my random variable x. So that's 0.25. The Q value, which is the probability of failure, is going to be 0.75. And then we go from there. Okay. Not there. There. All right. So let's go to the black color. Let me show you. If you remember, I had you guys do this in class, and we did a few of these, if I remember right, before moving to the technology. And again, this is a summer 10-week course. So moving to the calculator, I probably moved a little quicker than normal. But when we started out, in order to find these probabilities, I can very easily just use the formula that we derived using a combination. So the probability of some value x is going to equal n factorial over n subtract x. I'm about to square it. N subtract x factorial x factorial times the probability of success to the value of x, whatever that is, times the probability of failure to the value of n minus x. And if you remember in class, we talked about some of the patterns that go along with this. In other words, the sum of these two, right? There are some patterns there that you could work with. I got to remember to go back to this. The sum of these two. There we go. Good news. I like you. So if I was, I'm not going to work through this whole thing, although I might be able to get through it. If I'm looking for, in the case of the A prompt in that previous question, it was looking for the probability that we get exactly 3 of those 5 questions correct by randomly guessing the answer. Okay? Well, n is the number of trials, so that's going to be 5 because there's 5 questions. So 5 times 4 times 3 times 2 times 1. I'll put that up there. N minus x, the x value is 3. N is the number of trials. That's 5. 5 minus 3 is 2. So I've got 2 times 1 right there. The x factorial is going to be 3 factorial because this is your x value. And so I'm going to just undercut here. And the reason I do that is because in a larger problem, that would take out a good group of them. I could pull them completely off top and bottom and then just be left with what I'm left with. In other words, I'll come back to it. Hold on. Probability of success is 0.25 to the 3rd power times 0.75 to whatever's left. N minus x is 2. 3 plus 2 is 5. So 1, 1, 1. So I'm left with, see if I can squeeze it in, 20 divided by 2, which equals 10, times 0.25 caret 3, not a hard one, 0.016 times, and let me put these in parentheses because the little dots are getting confusing. Then I got 0.75. Let's stay accurate after a long day of work. And we're going to square that. 0.75 squared is 5625. I squeezed it in, yay. Part of it's underneath my big head. But you get the idea. I've got these values, and then I get 10 times 0.016 times 0.156, 5625. I knew that didn't look right. 5625. Let me double check what I put. I've got 10 times 0.016 times 0.5625. You notice that, I mean, I've done these problems, a kabillion of them, right? But I still go back over my work because it's so easy to make a mistake of looking here and writing it wrong. You just saw me do it. It's been a long day of work, so it's easy to do that. So it only takes me a half a second to check back over it. All right. Entree. I got 0.09. So I'm going to write this at the top, and then I'm going to erase this off. And we're going to go, I'm going to write this probability at the top. We're going to check it. I'm going to build the table below. Then we're going to find it using the calculator, which won't take me long at all. So what color do I use at the top? I don't know. Let's go gray. So let's go to the probability that we get exactly three successes, the 3 problems right out of these 5 is going to be, what did I say it was? 0.09. We're going to double check that. Maybe I made a mistake that I missed. I don't know. One way of getting it, kind of the long way, if you like doing it this way, I actually do for a smaller problem. I just enjoy it. It's the art of it, but you don't have to. Let's build the table. We're going to construct this binomial. And it's going to look like this. We'll go blue. So you've got your values of your random variable x, possible outcomes, and your probabilities. So in 5 questions, there is a chance you could get 0 right, 1 right, 2, 3, 4, 5. Again, back to a common error. People will omit the 0 sometimes, but 0 is a possibility in the sample space for this random variable because you could get 0 correct. I already said this was 0.09. My Apple Pencil's low again. I got to finish this out. So let's put these numbers. Let's see, it's 5.25. That's all I need. So let me scroll over to my calculator. And if you remember, we're going to use the vars key for this. And the second function is distribution. So I go second vars, brings me to my distributions. I scroll down to we're doing binom PDF, so probability density function. That's what we're working with because we're looking for exact values tonight. That's what we're looking for. So I hit enter. And then the syntax is in alphabetical order, NPX. So I would go in, which is 5, comma. The probability was 0.25, comma. And the X in this case was 3. Was my answer right? 0.09? Yes. Good enough for government work. I put 0.09. Just rounded to 2 places. The illustration of the work is more important at this point. You'll know in your assessment how many places to take the rounding out to. So now let's look at it from a different standpoint. I could certainly hit second, enter, backspace, hit delete, hit 0, go there, and put point. We'll just keep it at 2 places. We'll go 0.24. And then I could go second, enter again, backspace, hit delete, hit 1, point, we'll put 0.4 at 1. Second, enter, backspace. This is not necessarily the long way for a problem like this. It takes you really not that much longer to do this than it does some of the other stuff we're about to do. Put in a 2, hit enter, 0.26. Once again, this rote exercise, and then I go, I'm left with 4 and 5, so I go there. At 4, we got 0.01, almost 0.02. Second, enter for the last one, delete that value, hit the 5, go there. Ooh, I've got that e to the negative 4. Well, that's times 10 to the negative 4, so I'm going to have 3 zeros there. I'm going to have 0.000, and I'm going to go 2 places out. Significantly. So 1, 2, 3, 4. Yeah, I got it. So there's what I got for my answer. Now, that was the long way, and that really wasn't that long. Take you about a minute to do, if that. So I'm gonna hit clear because I'm a little OCD on that screen. Then I'm gonna go back to second vars, scroll back down to binom PDF. We're gonna do it the other way that I showed you in class. If you weren't in class, pay close attention. All I really have to put in is the n, which was 5, comma, 0.25, which was the probability. And then I close the parenthesis. I hit enter. It gives me all the probabilities. However, it gives it to me spread across the screen. Now, in this one, I could probably pull them right out, although it's a little bit of overlap to the left here. If you have a lot of numbers it's going to push out, it's just going to be a pain. An easier way to pull out all these numbers for your table that you have to transpose on paper is to go to the store key, second 1. We're going to store all these values in L1, hit enter, it's done. I go to stat, enter. Let me clear this out so it's not confusing. This is our old work in L2 and 3. There we are. There's the one that's highlighted is the 0.24. The next one is 0.4. The next one is what we have is 0.26. Remember, I rounded it to 2 decimal places. You'll know on the assessment how far to take it out. In this case, I'm just keeping it simple so I can write it up here. For 3, we have 0.09. For 4, I had 0.01. And for this last one, I had 0.00097. Bam. Right on the money. When I go back to my table, I've already written them in as we were doing them. There it is. I've completed the table. Now, the problem asked a couple of more things, and I'm going to go back to that. It's at this point of the stream for online office hours that will say, are there any questions from people who are watching? And there are people that's showing up. There's at least 2 folks in here. But you may or may not be from my class. I haven't gotten anything so far. It's okay. Or you may be eating supper. You don't want to add anything right this second. No problem. Or you might just be strangers who got stuck here and you forgot about it. Your phone's got you stuck in this. Anyway, okay. So let's scroll back over here. Exactly 3 answers correctly. That was A. Now for B, which is right here, where I want my arrow. Where's my arrow? For B, okay, at least 3 answers correctly. So at least 3 answers correctly. So what is the probability to answer at least 3? Probability, that's mighty bright, sorry. Probability at least 3 answers correct. Well, at least 3 means that at a minimum you got 3. But that also includes 4 because that's at least 3. And 5 because that's at least 3. So you have to take this, add it to this, add it to this. So now it becomes that the other one that's up there, CDF, you could work with cumulative density function, although I didn't show it in class the other night, I don't think. So I'm not going to go down that road here. I'm going to keep it based on the table itself. Because I think with an assessment coming up, I think you've got enough on your plate. So what this becomes is the probability that it's exactly 3 plus the probability that it's exactly 4 plus the probability that it's exactly 5. And that becomes 0.09 plus 0.01 to 2 decimal places plus 0.00097. Let me add those up. 0.09, that's 9 pennies plus a penny plus not even a penny. 0.00097. I got to 2 places. I'll write the whole thing out, but basically the probability that you as an individual that's guessing the answers, you have no idea what the answers are, and you're randomly choosing the answer choices from 4 answer choices on 5 questions is 1.10097. Is that taken out to 5 places. Now I had these to 2, so that doesn't make sense, but on the calculator that's what I got. So I'll pull it out just to illustrate. And that's it. There it is. So I illustrated on the calculator again. Again, this isn't brand new, but this might be a refresher for you. You might be, oh yeah, I remember now. Hopefully this helps you for the test. For the and I'm gonna cut the stream right there, I think. But I got to tell you, I'm stoked about Restream again. I had gone away from Restream because it was a tad bit expensive, but I've gone back to it. I was using Ecamm before, which is also expensive, but Ecamm I could do a lot of other things. But this is so simple, and this is all I need for streaming for my class. And the stream, again, this is not a class, this is online office hours. So I've been able to go from my work over to the problem set that I gave you for homework, which was a smorgasbord of things that I had put together to try to help you for the test this Wednesday. And then over to the calculator, TI-84. And again, this TI-84 online sometimes is a little wonky from the one we use in class, but as I've told you many times before, anytime during an assessment, and we don't use calculators on the quizzes, I don't allow that, but on the test, you're more than welcome, as long as it doesn't give away the answer, or as long as it doesn't give away the problem itself. I will work with you on syntax with the calculator if you've forgotten it all day long. It's not a calculator class, it's just use of a calculator. So you can come up and ask me, where is binom? I'll show you. I'll walk you through it. Again, as long as it doesn't give away anything. And remember, you can have a 3x5 card on your assessments front and back. Anything you want on there is fine. My philosophy on that is that once you fill that card up, you already know everything that's on that. Anytime I've ever had the chance to use one, I glanced at it, but I never had to go back to it. So you can bring a 3x5 card. I'll have calculators for you provided by the college if you need them, if you need to borrow them. Then we'll clear those back out before we turn them in. And then don't forget that the homework set that was handed out in class last week, and if you missed class, it's posted up on the Moodle. Don't forget to print that, complete the problems, and bring them in tomorrow night. I cannot emphasize that enough. And I think one of the other things I said in class was, I've done this for 23 years. And so if you, at least this course for about 23 years. So if you come into class and you're doing the note card when you come into class on the day of the test, and you have to tear a sheet of paper that's kind of 3x5, you're not prepared and you haven't done anything all week. So at least fool me and come in with a completed 3x5 card so I have confidence that everybody's going to get a good score on the exam because we prepped for it, practiced for it, and learned something through our discussions in class. All right. That's all I've got. For anybody that comes back and watches this on YouTube, I will have it posted on my YouTube site. I take that site, that URL, and I put it in the Moodle for my students, so the students can come back and see this if they weren't able to get on tonight. But again, I'm stoked. I'm stoked about GoodNotes. I just got to figure out a few things, but I appreciate anybody that came on during this time, and I appreciate anybody stopped by and any support. So if you like the YouTube site, or if you subscribe or you leave a comment, just say, hey, Mike, nice job, man. Or, hey, Mike, work on this. Give me some critique. It doesn't bother me. But the fact that you're interacting with me helps me improve this stream going forward. So, all right, that's all I got. Thanks again for being here. And if you're in my class, thanks for watching the video on demand. See you tomorrow night in class.